I have read saying if I say backbone
Mm-hmm.
network is the network where all the links are connecting.
Okay.
Correct?
Mm-hmm. Yeah, I would discuss on that. I mean,
Okay.
yeah, I mean, I would say that that's a backbone network is a different thing. Okay. The
Okay.
terminology which was I was calling about the architecture.
Uh-huh.
So architecture is a main thing I can say. Instead of saying backbone, I would say that architecture is a major factor which would be affecting your network security, network redundancy, and network expansion. Okay, so that is playing major role. But in this, we are going to learn all those things. We are going to understand what is a backbone. Okay, what is the core, what is the access layer, all those things we are going to cover. Okay, so we have different types of network design. Basically we can go with the 2-tier design, 3-tier design. Okay, and the fabric capacity planning, that a particular networks would be supporting how much bandwidth, that is a fabric capacity planning. So for example, if someone is saying, let's say we they just want a switch in such a way that this switch support around 50 Gbps bandwidth. Both of the switch should support 50 Gbps bandwidth. When
Okay.
I say 50 Gbps, so that means on the back end there would be system or the server which are connected. They would be generating around 45 Gbps of traffic. Around 45 Gbps of the traffic they would be generating, and that's why they just want to increase the bandwidth of this switch so that it can support more bandwidth. Okay, so we are going to talk about that into the fabric planning. Okay, and here in tier 2 and tier 3 we are going to talk about um, in tier 3 we are going to talk about legacy network design, which was access layer, distribution layer, sorry, distribution layer, and then core layer. Core layer. Okay, and in tier we are going to talk about border leaf kind of design. Okay, that we use in the SDN, software defined network. So if you have heard about Cisco ACI, okay, in this infrastructure we are going to use 2-tier architecture. Instead of using 3-tier architecture, we are using 2-tier architecture. And this 3-tier architecture you can see in the legacy data center, the data center where we are not using SDN, software defined networking. So there we are using this 3-tier architecture. Yeah, so we will talk about that in detail later, but for now I'm just going to make you aware about the course content so that we should be clear. We are going to talk about high availability technique. So you know FHRP and SSO, that is a single sign-on. And if I talk about FHRP, so under FHRP we have these protocol: HSRP,
SSRP, VRRP, GLP.
correct, VRRP.
SSO, this is the first time I'm
This
checking
is
this.
SSO single sign-on. Okay, so we'll talk about that.
Okay. I believe
VRRP,
SSO was not there in the CCNA topic.
yeah, right. SSO was not there in the course earlier. This is a new course, and you would see that automation is also part of that. After this, we will talk about, after understanding all these terms, redundancy terms, we will talk about analyze the design principle, WLAN deployment. Okay, so we are going to talk about wireless deployment. What are the wireless deployment model, whether that is centralized, distributed, controllerless or controller based, or controller over the cloud, or remote branch. So here we are going to talk about those wireless technology. And one company is very famous of these kind of wireless technology, that is a Meraki. You might heard about that. This is again from the Cisco.
They have merged, right? Meraki.
Meraki have merged from into the Cisco, right? So this is
A
very
different organization,
good.
basically.
Yes, right. This was earlier it was in individual organization, then Cisco acquired it. So we will talk about this wireless deployment, that how you can do. Basically, when we talk about wireless deployment, so you might be seeing in the offices, we have different access point, and there could be a lot of access point on each floor. We might have 10, 5 these kind of access point, and those access point advertising different types of SSID. Some would be advertising guest, some would be advertising corporate, or some would be advertising IoT. These are the access point. So IoT device would be connecting to IoT access point, corporate user would be connecting to corporate, and if there is any visitor would be connecting to guest. So how the segregation happen between these 3 layer of the user, okay? So, and how these devices would be controlled from the central location. Okay, so we will talk about that what is the centralized, what is distributed, and what is the controller list or controller base. Controller could be you can deploy as a hardware, like WLC, Cisco WLC is there, wireless controller, and this controller would be controlling all these AP. So if you require to update these AP, or you need to put any policy, okay, let's say you just want to change the password of authentication into these devices. So how you can do change from the same place, single place. And sometimes what happen, sometimes the VLC, let's suppose VLC get failed. So what is the redundancy for that VLC, that we are going to talk in this part, okay? And what is the benefit if you are using cloud-based controller? For example, for Meraki, what we are using cloud-based controller for Meraki. So from cloud-based, you can access from anywhere, and here you can integrate SSO, single sign-on, where user can access cloud-based portal, and from there they can deploy the packages, deploy the policy, they can do the monitoring, all those things. So we are going to talk about that. Then we will talk
Amar,
about wireless.
Sorry, if you say SSO, single sign-on, shall I consider this is for the authentication, like the user will get one username password page just to authenticate himself, single sign-on, and once he authenticate, he can
Yes, you can do that. Yes.
That single sign-on, that means it's just for the authentication purpose.
Right.
Okay.
Okay, let me just clear this. So that's a wireless part. Apart from the wireless, we will talk about SD-WAN. What is SD-WAN? This technology is really very famous, SD-WAN. Okay, SD-WAN, SD-access, what are these things? So we will talk about that. Basically, SD-WAN is a technology which is replacing your traditional WAN into new mechanism. So I would say that how earlier your WAN network is being connected. Okay, so I'm just taking one design. Let's say this is my HQ data center, and from HQ we have connected different branch offices. We have branches at different place. How we were connecting to these branches? Let's say we have a user which is on the branch side, and the application, or our server is hosted where? They are located on HQ. Okay. So you can see here we have different, branches, and you can see here we have HQ. All the resources, application are here, which user are accessing from branch offices. So for that, what we require? We require some connectivity, right? What connectivity?
When connectivity?
We might be using VPN to connect them.
Okay. Site-to-site VPN.
Site-to-site VPN, right? We might be using site-to-site VPN.
Maybe MPLS.
Or maybe MPLS, that's correct.
If we say MPLS is the latest version of the, like, frame relay is old, right? Nobody's using frame relay nowadays.
Right.
Only MPLS.
Yes.
So
MPLS. Please line.
Sorry. It might be not related to this, but my question is, if I say MPLS, in MPLS also we are using any any routing protocol like BGP or EIGRP, anything like that?
Yeah, we are using that. MPLS is kind of, they are using some kind of label. Okay.
Yeah, labeling.
We talk about labeling switching. Okay.
Yeah.
It would be using, but yes, for routing purpose, yes, we are using those protocols.
Routing protocols we have to use either BGP.
We have to use.
Okay.
BGP, OSPF, whatever the protocol that would be doing the routing. So we have
even
to
for
use that.
Okay. First, even for frame relay, we were using the protocol, right? Routing protocol.
Yes, right. Right.
Okay. Okay.
I mean, there are two things: underlay and overlay. If you have heard, underlay and overlay. So if you talk about MPLS is a overlay technology. But underlay, what is running? Your routing.
Behind MPLS, like under the MPLS,
yeah.
Routing. Okay.
Routing would be running. Yeah. You might be using OSPF or BGP. These are the two famous protocols that would be used
under MPLS.
Yeah, under MPLS. Or
EIGRP is not that much.
EIGRP can also be used. However, due to, I mean, earlier EIGRP has some dependency, that vendor dependency. Later it was open, but you know, the people who are using already OSPF, okay,
yeah,
they still rely on OSPF. However, EIGRP is better, but for that entire infrastructure need to be changed.
Correct.
So OSPF and one more protocol I'm forgetting, that is ISIS. Yes, right here. So these protocols are very famous, especially I have seen in ISP cases. They are using these protocols a lot.
Yeah, so to be very honest with you, Amar, ISIS, if you say ISIS, I can only read ISIS. Apart from that, nothing, no information about ISIS.
Okay. No problem. I think in CCNP, we don't have a portion for IIS. Okay.
Yeah.
But in CCIE, we have some portion for the IIS.
But if you say, yeah, but if you say ISIS, where this ISIS protocol is using? In the ISP network?
In the ISP network, yeah. Mostly the ISP network are using that. Okay. If you go in the organization, so far, apart from ISP, I haven't seen this protocol used in any of the data center which in which I was involved.
Yeah. And you mean to say in the enterprise network, ISIS is not in use?
In enterprise network, ISIS is not used.
Okay. But service provider network, they are using ISIS.
Yes, they are using.
Okay. But we are not going to cover this ISIS, right? It's not in the system.
No, we are not going to cover this ISIS. In depth, we are not going to cover, but yes, overview I can give you, because ISIS is not part of our course.
Okay.
So yes, so yeah, I was talking about SD-WAN. So yes, let me just go here. So SD-WAN is going to provide you a latest way to do all these things. If I talk about traditional mechanism where you create a site-to-site VPN between these two branches, it takes a lot of time in terms of the configuration. and the troubleshooting. Okay. It take very long time to troubleshoot and create the site-to-site VPN. If you have already done site-to-site VPN between router to router, so you know that what all the commands you need to run and how you can create the site-to-site VPN. So it takes a lot of time to do that. What the technology we have came SD-WAN technology, where one of the device which is known as a controller, which would be installed on the data center, and a kind of router device that would be installed over here. Okay.
On the branch side.
So there are three parts to manage this device. There is a management device, and that management could be on the cloud, or you can install that as well. So this is storing all the policy. That policy you can push over here, which is known as a hub device, and this is a branch device. So that policy you can push over here. As soon as you put the policy, basically these branch device would also connect it to the controller over the internet. So when you push the policy, it would take very less effort to create a site-to-site VPN. Okay, and you can create a policy on this, that how much traffic you should go via this site-to-site VPN and how much traffic can go via MPLS if you have two different redundantly. What happened? MPLS is based on, I think, data billing happen on the databases. Okay, I mean how much data is going to transfer on that case. This link, this site-to-site link, it could be broadband connection. To connect a branch office, you don't require to use MPLS. You can use this MPLS itself, sorry, broadband connection itself, normal internet connection to connect to these branches. And the deployment is very easy. Okay, these devices not only providing connectivity, but from here you can control the traffic itself. How much YouTube traffic should be allowed, what kind of
access policy
URL should be allowed. All those firewall rule you can create itself on these devices. So this is really very good technology, SD-WAN. Now you would be able to manage your WAN connection very easily. Earlier, how you would be managing? If you require to manage that, you need to remember which switch or which router is installed on which location. So for example, let's say any problem came. Okay, I still do remember those days. If any problem came in, let's say, in one branch, and that branch in, let's say, in Jacksonville, in US, so I do need to remember what is the IP of that Jacksonville router. I do not need to remember, and I need to make sure that the connectivity between MPLS should be established. Then I can take the remote of this one. Else I can't take the remote of this this router. Okay, from here, if I'm on data center. Now what is happening right now? If let's say this connection gone break, but still it has the internet connection. From here, from the cloud portal, I can manage this device. So that's what the benefit of SD-WAN. So this is known as a software-defined WAN. Like we have SDN, so SDN, software-defined networking. This is for LAN. We have SD-WAN, software-defined WAN. Okay, and we have different solution.
If you say SD-WAN, is it like replacing the MPLS SD-WAN?
It's not replacing MPLS, but it's to manage your branch office connectivity, hub and spoke connectivity. For that, you can use the SD-WAN. It would not replace MPLS.
Okay.
It is reducing the cost. Okay, you don't need to use dedicated line. Why earlier we were using dedicated line? For security purpose. Yeah. For that we were using the dedicated line. That on this line nobody can place the data because this is dedicated for us. What is the else we were using earlier? I mean, how we were compromising this? I mean, compensating this. Let's say if somewhere we don't have an MPLS line because we have just two users. And for 2 user, we don't require that MPLS line. That's a dedicated connection in some branch. So what we can do,
Amar,
we can use site to site.
if I say MPLS, it's not a dedicated line, right? Dedicated line is lease line.
It's a dedicated, MPLS is a dedicated. Lease line is also dedicated, and MPLS is also dedicated. If you purchase the MPLS line, both are dedicated. These are not shared. When I say shared, that means nobody, whatever the circuit got enabled for you for MPLS. MPLS is example of, packet switching. This is example of packet switching, and this is lease line example of a circuit switching, right? Whatever the virtual connection is going to enable between you and your destination, in that virtual connection, nobody can place the traffic. That virtual connection would dedicated for you only. That's what the MPLS. And so I can say this is the dedicated line. Nobody can share that. But your broadband, this is a shared line. And that's why in broadband, you are getting CIR value. This is committed information rate.
Yeah. But in frame relay also the same thing, if I'm not mistaken, Amar.
Yeah, frame relay on same thing, but they don't have a labeling on the on the packet.
On the packets, yeah. But if frame relay doesn't have labeling on the packet, MPLS have the labeling on the packet.
Labeling on the packet.
The CIR, yeah. MPLS will also have the CIR, right? Committed rate, information rate. My confusion is only the lease line is the dedicated line for you. You have to pay more. More means very high amount for the lease line. But if I go for the broadband connection, with the help of broadband connection also, I can run the MPLS. Because I'm taking one broadband connection from any XYZ provider, and from the with the help of that, I'm using the MPLS connection of that service provider cloud. Am I correct? No.
Yeah, you are correct, but when I said that in that virtual circuit, nobody else can place the data. That's I said. But in broadband, this is a shared one, so everyone can place their data. And for compensating broadband, we have site-to-site connectivity. So whatever the data you are placing in the MPLS, that is a secure, okay, that would not share by the other people.
Yeah.
Other people means if someone is connected from the same terminal, so they won't be able to read those data.
Okay. Sorry to take your more time, but if I say lease line, so I'll go to one provider. I'll say my one branch is in location A, one branch is location B. I want one lease line. So what the service provider will do, he will just give the connectivity. Nobody will use this connectivity. In the cloud, service provider will do anything in his cloud, but nobody will interfere in my connectivity. That's called the lease line. And I'll get the whatever link I have requested for, like 256 Kbps and whatever for the lease line. That's the correct, right? From location A to location B, the lease line.
Right. It's location to location. Correct? That's correct.
Yeah, yes. Location A to location B. It's a lease line, like point to point. Nobody else will interfere in between. Now the second thing is if I go to the same provider asking for the MPLS, but I have different locations, like 4 locations, A, B, C, D. So all the 4 locations will have the full mesh with the MPLS. So I just need to go to the provider and ask for the connectivity for all the 4 locations, right? I don't want to ask for the MPLS to the provider. So once the MPLS gives the connectivity to me, to my office location, A, B, C, D, so I will take the connectivity. I'll whatever IPLS and all I'll configure, and I'll configure the MPLS in my for my 4 locations. Will it work in that way?
Yeah, it would work. Yes.
Right. That means the connectivity which I'm taking from the service provider, I don't want to tell the service provider I am going to use the MPLS, or I have to tell the service provider I will gonna use the MPLS. So
I mean, they would offer you. they would offer you whether they are providing the service at 4 location. They would offer, going to offer you that we have these type of lines, which line you want to take. So and
Okay.
for that they would have a different plan, and they would be saying that on this line this is more secure, this is less secure, all those things they are going to offer.
Okay.
Okay. Yeah.
Fine. I think once we start, once we start explaining in depth, so I'll be understanding more on this. I believe.
Sure.
Some confusion, but let's go
No
ahead.
problem. So we will talk about that. No issue.
Yeah.
Then we have exploration principle of Cisco SD access. Okay, so this is again another solution to manage the SD-WAN. Okay, so yeah, so this is the SD-WAN part that we are going to cover, and post that we are going to cover QoS. What is a QoS? That is a quality of services. Okay, so we are going to talk about QoS. We are going to talk about class of the services, COS, all these value we are going to talk. How we can implement QoS policy. What is the default policy for video and voice traffic? All those things we are going to talk about that how it is going to identify this is priority traffic, this is not priority traffic. So in the concept itself, we are going to talk about that. If some traffic rate required special attention, that how we can use the QoS on the wired and wireless network. Then we are going to talk about different types of hardware and software switching. So here we are going to talk about what is a CEF, what is a MAC address, what is a TCAM, that is Cisco explicit forwarding, right? CEF.
Cisco Express forwarding.
Yeah.
Forwarding.
And we are going to forwarding information base and routing information base. What is the difference between these? We are going to talk about that. So this is the part of architecture where we are going to discuss the thing. Then I would go to the virtualization. That is the next part. So in this virtualization, we are going to just understand the concept of virtual machine. What is the hypervisor? What are the types of hypervisor? Okay, type 1, type 2. We are going to talk about virtual machine. Then we will discuss about the virtual switching. And after virtual switching, we are going to talk, we will go into the router, and we will talk about VRF, virtual, what is the full form? Virtual router forwarding, right? Yeah. So we are going to talk about VRF, then we are going to talk about GRE, okay? Generic routing encapsulation protocol, and IPsec tunneling, we are going to talk about that. So here we are going to talk about that, what are the benefits if you are using GRE, and what is the benefit when you are using GRE and IPsec, all those tunneling, we are going to talk about that. Okay. Then we are going to talk about Lisp and VXLAN. Okay, so VXLAN is a new concept, right? So we will talk about that in the virtualization. So these are the virtualization terms. Here we are going to discuss that. And then after virtualization, Amar, we will go to
virtualization. What is that? Sorry, but what is virtualization?
Okay. So when we talk about virtualization, so there is a, instead of using physical infrastructure, or you can use the virtual infrastructure. So you can do the virtualization on the hardware level, or you can do the virtualization on software level. So when I say hardware level, so let's understand in this way. We have the hardware. This is the hardware we have. On this hardware, we have physical component. We have CPU, we have RAM, we have hard disk, okay, and we have network interface card. Okay, so if I install any operating system, let's say I have installed Windows on this, So this Windows is going to consume the CPU, RAM, hard disk, network interface card. But maybe it is not going to consume 100%. Maybe this Windows system, nowadays we have high CPU. You can see that 8 core, 12 core CPU we have. So this Windows system may be using 2% CPU. Maybe it is using 10% RAM. Or maybe this would be using, 3 to 4% HDD. Or maybe it is using 2% of network interface card. Because nowadays you can see that network interface card is supporting how much bandwidth? 1 Gbps, 10 Gbps, this much it is supporting. Okay, that time has gone where network interface was supporting 10 Mbps, something like that, 10 Mbps, 100 Mbps. That's gone. Now,
And,
what?
Amar,
Yeah.
sorry, if you say network interface card, uh, so this fiber optic cables is also we are putting in the network interface card, right?
Yes, right.
Correct. Correct. So
Yeah,
40
we
GB
can.
and 100 GB also.
Yes, right. So we can use either we can use any media. We can use wired or wireless. In wired we can use coaxial, not coaxial. Coaxial we can
UTP
twisted
and
pair. Twisted pair we can use, or we can use fiber optical.
Okay.
We can use any one. Okay.
But
if you go on the fiber, definitely you would getting more throughput.
40,
100. Yeah, right. So I can go here and I can let you know that this is the what? This is the physical machine on which everything is installed, operating system is installed. Now what computer scientists thought that what we can do so that we can utilize more hardware. Okay, so they created one layer which is known as a hypervisor. Hypervisor, that's a virtualization layer. Okay, so they created one layer or one software which is known as a hypervisor. What hypervisor do? It allows us to create virtual infrastructure, host a virtual infrastructure, to create a virtual infrastructure. Hypervisor is allowing us to create a virtual infrastructure and host the service on that. So you would have, this is the physical CPU. When you install the hypervisor, you can create a virtual CPU as well. Okay, so now you can create a virtual CPU. You can create virtual RAM, and you can create a virtual hard disk. Okay, and you can create a virtual network interface card. So now under this hypervisor, you can create same set of the hardware virtual infrastructure, and now you can host the same operating system over here. You can host Windows, or you can host virtual. Yes, right. Now you have the virtual layer, and maybe now the physical utilization of CPU go increase. Maybe the virtual hypervisor which you have used over here, virtual CPU that you have dedicated for this Windows machine, it may be consuming 10%. So the physical CPU utilization would go to 10%, 12% around. Yeah. So that is the virtualization where you are creating, where you are doing the replication of your physical infrastructure into the virtual infrastructure. Okay, so that's a virtualization. So similarly, you can do the virtualization on what level? You can do the virtualization on the hardware. This is known as a hardware level virtualization because you have done the virtualization of your hardware. Correct. Okay, so this is not only limited to the server. Virtualization is one of the famous technique that can be happen in the anywhere. It is on server, it could be under the firewall. Okay, or it could be happen on the router as well. Okay, you have earlier what was the doing this firewall? This firewall was running one instances, just a single instance. Okay, over here. When I say instance, that single processing of the firewall, this would be running. When it did the virtualization on the firewall itself, now it can run more instances there by using. When I say more instances there, that means the similar type of here. Earlier, this server was running how many windows? Just one windows. When you did the virtualization, you can host multiple windows, okay, on the same server. Same way, earlier this was running a single firewall instance. When you did the virtualization, whatever the capacity of this hardware, according to you can run multiple instance. So let's say for this hardware, the capacity is a 6 instance. Okay, so you can run 6 virtual firewall, and you know the traffic between those both instances would be segregated. So one instance you can use between internal to external, and other instance you can use between DMG to external. So this kind of virtualization you can do. Earlier, let's take example of router. So earlier there was one routing process was running. One OSPF could run over here. Just one OSPF instance could run over here earlier. But when it did the virtualization, their routing segregation can happen. Okay, the multiple OSPF instance can be run over here. Okay, using a VRF, and routing could happen over here. So from the same network, same interface, you have a 3 different segment is connected. One for internal, one for external, and one for DMG. You have physical interface, it's just one, but from here you are connecting your 3 instances, and you are creating a 3 different VRF, so that it can segregate the routing table. So within the router itself, you can do the virtualization. That means your physical infrastructure, you can replicate to the virtual infrastructure. And even though your software level virtualization you have done, your routing instances, you have changed this. Here, what you have done, this is the hardware level virtualization. But underline the software, which is routing protocol, you have done the virtualization and you have segregated different VRF as a different VRF. Okay. And so what is the
Amar, sorry, I don't know the DMG.
Yeah, DMG. Okay, I can explain that. What is the DMG? Let me just clear this. So basically what we say in our routing, so you might have seen that in the border, Pakistan has their own boundary, their own fence, and India has their own fence. Okay. And this area is known as a DMG area. This is a demilitarized zone. That means anybody can access this. If they're required, they can access this area, but they cannot touch their fence. Okay. So same way it is a here. In network we have
beyond the boundary.
Beyond the boundary, I can say. I mean, let's say we have defined the network in this way. Okay. Let me just clear this, and okay, I can explain in this way. We have a firewall. Okay. In this firewall, we create a 3 zone usually. One is internet. This is known as a public zone.
Okay.
This is a public zone. That means up to here, anybody can come. Okay. Up to here, anybody can come. Then we have private zone. This is a private zone.
On the employee
Okay,
screen.
which is internal.
Mhm.
This here, who is residing? Internal
Employee.
employee.
Okay.
Internal user, I would say.
Okay.
And then third, we have DMG, where internet people can also come, but in a different way. I would let you know.
Okay.
These are the servers where we place especially any service which is internet facing. So might be we have web server,
Mm.
okay, where is my website is running and people are accessing from their internet.
Mm-hmm.
Might be we have
Exchange.
FTP server.
Mm.
Yeah. Might be we have exchange front end facing, right? In exchange
Okay.
itself, we have one role is called transport role, I think. Exchange transport server.
Mm-hmm.
Okay, I don't remember because since exchange 2013, I haven't worked on the exchange. So we have some server which is internet facing, but on these server we can't assign the public IP directly. We have assigned the private IP.
Okay, sorry, private IP.
All these server have the private IP, but the thing
Okay.
is these are the internet facing. On the firewall here we have public IP, and these are the server which is netted.
Netted. Okay.
Okay, what kind of net is configured? Inbound net, not outbound. Inbound net configure.
Okay. Inside.
Yeah. So what we are allowing these user who is over the internet, if they want to access our application, which is hosted on DMG, they can access our application. Okay, they can access our application, but not directly. How they can access? They would be hitting the public IP, which is netted one. The firewall is doing that and sending them over here. Okay. However, this is a security. But what if this server got hacked? If this server got hacked, okay, so this entire, I mean, the hacker would have access to this FTP as well, exchange as well, so it can compromise these things. However, this is a public facing, so risk is there. My organization is buying the risk. They have agreed on the risk that yes, on each DMG there is a risk. Okay, if there is any vulnerability, and just because of that server gone. But anyhow, the critical service, a confidential service which we are putting over here in private zone, we would have a user. What we would have an Active Directory server. We have databases. All the databases would be here. Okay. So demilitarized zone is the zone where internal people can also access and external people can also access. So this is the network. This is why this network is known as a demilitarized.
DMG.
Okay. Demilitarized. I told you that border. So India can also access that area and Pakistan people can also access that area, but they cannot touch each other boundary. Otherwise, ceasefire. Yeah.
Some other thing will happen.
Yeah.
But our in like as per your experience, you have Radhe was saying you have a lot of experience in this networking. So it's happening like we are getting the attacks on the DMG side.
Yes. A lot of time we are getting the attacks, and that's why we have tool and technology to to break that attack, mitigate that attack.
That's why we have the firewall in front of DMG, right?
Yeah, I can let you know few technology. We have the web application, right? So we have this firewall. Apart from this firewall, we have another firewall we put in front of this web application. We put WAF.
What is that?
We put WAF. WAF is another kind of firewall, which is known as a web application firewall.
Web application. Okay.
You might heard about this web application firewall.
Okay.
For these kind of services like Exchange server. Exchange server also gets attacked, and for that, what we put? We put email security gateway.
Okay. It's a Cisco thing, if I'm not mistaken.
I would give the name of that security gateway, and that is known as a ESA, email security appliance. WSA and ESA. This is email security appliance, and I think Iron Port was the one device which was using as a email security gateway. However, there are other vendor. You might heard about FireEye. This is another vendor that is very famous for the email security. So for different type of services which is exposed on internet, we are putting additional controls there. Yeah. Let me just clean this. Sorry, you were asking something?
No. Alhamdulillah, DMG is clear now.
Your voice is very low for me. I don't know
DMG
if
is clear now.
sorry, can you just come in? Let me check. Okay. Let me just increase the volume level of speaker. Can you speak now?
Yeah, DMG is clear now.
Okay, DMG is clear. Okay. Okay, so I was talking about, just give me a minute. Let me just shut the door. Yeah, so I was talking about
Amar, right?
Yeah, right, Amar.
Can you help with the full name also, Amar?
Amar Kumar. Okay, so I can go back. Apart from virtualization, we have infrastructure. In infrastructure, this is 30%, and here you would be learning routing concept, netting concept, all those routing kind of protocol, layer 1 concept. Okay, all those things you are going to learn over here. So here we are going to talk about 802.1q trunking protocol. We are going to talk about spanning tree protocol. Then we are going to talk about, this is layer 2, and then we will move to layer 3, which is routing protocol. Then we will talk about wireless over here. And after wireless, we will talk about IP services, which is, IP services is kind of, this is not a routing. Why this is a different than routing protocol? Because here we will talk about that, what are the services which is based on the IP addresses. So NTP is the one, okay. Netting is the one, NetPat, HSRP, VRRP, these are the one, okay. And we have multicast as well. We have PIM and IGMP. We are going to talk about that. So this is the infrastructure part. And then we have network assurance. So in network assurance, we have, we have different types of tracking, and we we need to make sure that how our network is secure. I mean, basically, how we can get to know that my network is working well or my network is not working well. Okay, for that, sorry,
high availability.
Yeah, high availability, etc. But what is the mechanism? If network gets failed, then how I would know that my network is failed, that this part is particularly failed? So here we are going to talk about most about the monitoring. Okay. So here we will discuss about, debugs. What is the conditional debugs you can put? What are the trace route, ping, SNMP, syslog? Okay. What is net flow? Okay. What is the remote login? What is span, rspan or ER-span? We will talk about IPSLA, which is tracking of the services. Then we are going to talk about Cisco DNS Center to apply the configuration, network configuration and monitoring management. We can use Cisco DNS Center. And then we will talk about configure and verify netconf for our restconf. Okay. So these tools we are going to talk about this network assurance. So basically this is mostly related to monitoring, configuration, and troubleshooting. Then we have security. This is again very good thing. Okay, we are going to talk about security, where we are going to talk about what are the different lines we have. You know, we have console line, line TTY, or line VTY, auxiliary line we have. So how you can secure that? That this is really important, and here somewhere the people get missed. Okay, so this is very basic. Okay, but most of the people forget to configure the security of this. Okay, so yes, this is really important. So how you can configure, protect different lines, how you can do the authentication authorization using AAA, and how you can verify the infrastructure security based on the ACL or COPP. And then we will talk about REST API security. So if you are using any API to configure, to monitoring, or to get any value, so for that, what are the REST API security that we are going to talk about that. Basically, your Cisco device is supporting REST API. This is nothing but this is a API format. Okay. So yes, so all these devices, Cisco devices supporting that. And then we are going to talk about wireless security, where we are going to talk about EAP, web auth, and PSK, which is pre-shared key. All these things we are going to talk. And then we will describe the component for the network security design. What should be the threat defense? What should be the endpoint security? What is the next generation protocol? What is the trustsec and MACsec? And how you can control the network using 802.1x authentication, or map-based authentication, or web-based authentication. So here, this is really very important terms. Basically, we are going to talk some, I would say, some of the ICE part over here, Cisco ICE. Okay, so we will discuss about that, because 802.1x map, these are the part of Cisco ICE. So we will discuss about that as well. And finally, we have automation. So in automation, we are going to talk about different types of what is the basic use of the automation. So let's say if you have thousands of device, and in those devices you just want to update some settings. Okay, so how you can do that? Okay, how you can do very quickly in all those 100 or 1000 devices. So via scripting, basically you can connect to them using a script, whether that is a legacy or that is latest device, it doesn't matter. All the device supporting those kind of script. So using scripting, how you can interact with those device, how you can construct the JSON file. Okay, JSON is another format of automation script. Then we will talk about high level principle or benefit of data modeling language, such as Young. Okay, there are Young template using which you can do the data modeling. We will describe what is API and how it can use with the Cisco DNS Center or with vManage. And we'll also talk about interception of REST API response code. Okay, so there are different response code of REST API. So we'll discuss about that. What is the successful response code and what is the failure response code? And here we are going to use Cisco DNS Center for REST API configuration. And finally, we are going to talk about construct EM applets for automating configuration, troubleshooting, and data collection. And then we are going to talk about different types of agent that is going to install into the router, such as SEP, Puppet, Ansible, or Salt Stack. These are the agent. So this is a overall syllabus that we are going to discuss. Okay, and the lab access would be similar. Okay, So you can access the lab from here itself. Right now, that lab is not published for me, but yeah, I would ask Joya to publish that lab. So you can access the lab. And similarly, as you get the workbook or as you get the recording, you would get same thing over here as well. If there is any kind of slide, so definitely you would get the slide as well. Okay, so this is the what basic things we have. If you have any other question regarding this course or syllabus, you can ask me. Else we can continue from tomorrow. Okay. Once we get the lab access, we'll try to show you that what is the basic purpose of this lab, what all the device, and how we can do different types of practical there.
Yeah, sure. Amar, how many hours it will take? Like how many days it will take to complete this course?
So basically, this is 60-hour course usually.
Okay.
30 hour for each one.
30 hours for each one means?
I mean, we have two domain right here, routing and switching. So yes,
okay,
30 hour we have divided.
30 hours for routing, 30 hours. Okay.
But if required to extend this, we can extend this. This is not hard coded. Okay. So we can extend this for 10 hour more.
Regarding myself, Amar, let me tell you, like I have done the CCNA, but not now. It's 2011. Then I did CCNP routing in 2013. After that, I got escaped from there. I came here and then no connection to the networking and all. Now, last week I spoke with Amar. I spoke with
Radhe.
And he said, okay, let's start from this thing. So in a week, I just find out some videos for the CCNA on the YouTube, and I watched some videos. But the thing is, like, I'm not able to answer questions. Like, if you see, I'm asking so many questions. Some are silly also, but still, I have some questions in my mind. That's why I come across in the classroom, in the environment where I can ask my questions and I can get the answers. Because I'll not be able to learn from the
that's what's this difference between online and offline. When you are in online, you can, I mean, maybe there are teacher which is better than me and experience is better than me. They are teaching there and uploading the video, and thanks for YouTube and this Google. Okay. But the thing is, you can't ask the question. If you have any doubt, yes, so you can't ask the question there. Even though if you put on the, comment somewhere, so you would get different answer from different people, and you would get more confused. So yes. But no, this is helping you at least if you are learning online and offline on both way. Okay, so this is helping you. Sometimes, let's say there is a trainer who is teaching you, but he forget to tell you any particular concept. Okay. But if you see the online videos, that is a topic by topic, right? So if you learn there and you do the cross question with your trainer, okay, maybe you would get more answer on that, more clarity on that. Yeah. So I mean, I would not say that online is bad or offline is good. The difference is the question you can't ask, or if you have any doubt, okay, and if that doubt doesn't clear, so next step when the person is teaching online means recorded video, so you won't understand the next concept because these are the interrelated.
Actually. And you already saw my questions, how it is.
I mean, I don't worry about that. Even though the question is very basic or very high, it doesn't matter. Okay, because I'm the one who I have already gone through that phase. Okay. So yeah, I know that, and it's good. Even though you are asking, sometimes it feel like it's a very silly question or silly things, but that is a really requirement. I do remember the one line of MS Dhoni. Okay, so he is saying that sometimes you have to tell the common things for the people who don't know. He told that sometimes I need to tell the common thing, very common thing to normal teammates. But we had very experienced people there, Sehwag, Sachin, etc. For them, I was not explaining for them, but this was the team. That's why I was explaining in front of everyone. So sometimes our question would be silly, but you know, if your doubt does not get resolved even for the silly question, okay, you won't be going into the next step. Yeah. So it's really important. Ask the question to your trainer. Okay. I'm not that kind of trainer who just go point to point. Okay. If there is anything, any question come into your mind, you can ask to me.
We
It
already
doesn't matter.
follow, so we know. Rajesh said, I'll not be going to teach you, but Amar gonna teach you the Palo Alto. I said, okay, then not a big deal. I'll study with him, not a problem.
Okay.
Uh,
Okay.
the Palo Alto was good.
Okay. Great. Thanks. Thanks for your feedback.
So
Okay.
we're
Any
gonna
other
start
question?
tomorrow. Not a
Yeah, we are going
not
to
a,
start tomorrow at same time at
and
8.
at
Yeah,
8 o'clock, right? Yeah,
at 8
Indian.
o'clock.
Okay. And Amar, any other thing which you want to provide me online that I have to go through or something like that?
I would recommend to get the book as well. I don't know what is your habit in the reading of the book. If you doesn't get bored, so definitely go with the book as well. Okay. So I would
Then,
suggest there is an official guide from the Cisco itself. Okay. You can try to download this a book for this particular exam. Okay. So when you read the book for a specific topic, you would learn a lot, because book is the one thing which is going to teach you than any teacher or than any video, because in the book you would get detailed knowledge.
but I have to purchase this book if I'm not mistaken. Right?
There is official guide from the Cisco itself. I can share the link of that. Maybe we have somewhere in study material. Yeah.
For study material. Downloads.
Yeah, this is a kind of video, I
It's
think,
kind of
from
video.
them. From them, but if you go to download, there would be book as well. Okay, it's not showing anything as a book, but yeah, I know that there is a book, and this is easily available on Amazon. So here, download the official guide. I would let you know that what is the link from for the book.
No problem. Not a
Okay.
problem. It's just a
And
beginning, let's say.
yeah, so book is the important thing. Okay, book is really important, where you get more knowledge.